Hey y'all, so today in this experiment we're going to be testing hydrophobic and hydrophilic materials, testing the properties of plastic wrap and aluminum foil. So we're going to do this by measuring their contact angles with water and their roll-off angles using the software called MSE. Okay, so moving on to our materials and experimental setup, we first have our plastic wrap right here, which is a smooth, non-polar polymer, while our aluminum foil is a natural metal that has a natural oxidized surface. So these are going to be relevant later, but we're also going to be using this dropper, this little pipette, not really a pipette, but dropper, to be able to put 2 millimeters of water onto these surfaces, and we're going to test the angle using MSE, as I said earlier. So moving on. Okay, so let's do the plastic wrap first. So I'm going to put the camera down right here, and we're going to put some water on the plastic wrap. So water right here. We're gonna get exactly 2 millimeters. Actually, wait, we probably shouldn't be taking 2 millimeters, right? It's gonna be like just a drop. So cancel my 2 millimeters from earlier. We're gonna be putting 1 drop of water on plastic wrap. So here we go. We're gonna be doing multiple, so we can take the average. So I did 3. Perfect. They're not perfectly in line, but it works. And yeah, let's also do the aluminum foil at the same time. So 1, 2, 3. I can already tell a massive difference, but all right. So let's take these images and we're gonna put it into MSE. All right, so a little bit of a change in environment, but the plastic wrap had an average contact angle of 114.956 degrees, making it hydrophobic as the water beads up on the surface, while aluminum foil had an average contact angle of 33.54 degrees, making it hydrophilic as the water spreads across it. So why does this happen? So as for the hydrophobic material, water interacts well with the materials that have similar bonding. So aluminum foil forms the oxide layer on its surface, which is polar, and it allows the water to spread more easily, making it hydrophilic. While the plastic wrap is a polymer with non-polar molecules, meaning it repels water and prevents it from spreading, making it hydrophobic. Okay, so moving on to the roll-off angle. This is going to be a little bit hard because of the materials we're using. Plastic wrap and aluminum foil tend to both be like really like it's not really like a plain surface. Like it's not hard, so it's kind of hard to get an angle. So we're going to be wrapping these pieces of cardboard with these materials to be able to get the angle. So yeah, you can watch me do that. Here you go. You got 2 cardboard pieces with the materials, and we're gonna test them. Okay, so let's get the video of the water rolling off the aluminum foil. And then the plastic wrap. So as for the roll-off and sliding angles, here are the results. And as you can see, the plastic wrap had a roll-off angle of 38.79 degrees, meaning the water rolled off easily as expected of a hydrophobic surface. Meanwhile, the aluminum foil had a roll-off angle of 55.17 degrees, which is larger, meaning the water slid rather than it rolled off. So again, why does this happen? Hydrophobic materials like plastic wraps have a low surface energy, which reduces adhesion and allows the water to roll off easily or quickly. But hydrophilic materials, on the other hand, like aluminum foil, have a higher surface energy, meaning the water sticks more and moves in a sliding motion rather than rolling. So a couple real-world applications of hydrophilic and hydrophobic materials are as follows. So hydrophobic materials are useful in waterproofing, such as in like raincoats, car windshields, and self-cleaning coatings because the water rolls off easily. While hydrophilic surfaces are useful in cooling systems, adhesive bonding, and medical coatings where controlled wetting is required. So in conclusion, plastic wrap is hydrophobic, repelling water with a low roll-off angle, while aluminum foil is hydrophilic, allowing water to spread and slide off more slowly. So understanding these properties helps in designing materials for various applications. Thank you for watching.